Саламатсыздар ма, құрметті әріптестер? Диссертациялық кеңестің кезекті отырысы. Бүгінгі қорғау ағылшын тілінде болғандықтан, ары қарай ағылшын тілінде жалғастыруға рұқсат етіңіздер. Today, at the Dissertation Council at Al-Farabi Kazakh National University for the group of specialties, educational programs, automation and control, automation and the Internet of Things, intelligent control systems, artificial intelligence in medicine, computer science, computer engineering, system engineering, information systems, data science, computer science, computer engineering and the management, at which the dissertation defense of Muhit Januzakov for the degree of Doctor of Philosophy on the topic research of fault tolerance algorithms for reliable information processing under the educational program 8D06103, computer science, will be considered. The members of the dissertation council for the defense of this dissertation, dissertation in above mentioned groups of specialties was approved in number of 7 people, including 4 permanent members and the 3 temporary members. Permanent members, Timur Imankulov, Chairman, Associate Professor, Madina Mansurova, Deputy Chairman, Candidate of Physical and Mathematical Science, Joldas Buribayev, Scientific Secretary, Acting Associate Professor, and Balgaysha Mukanova, Doctor of Physical and Mathematical Science. Temporary members of the Dissertation Council, Rita Ismailova, PhD, Kyrgyz-Turkish Manas University, Aygerim Yerimbetova, PhD, Candidate of Technical Science, Associate Professor, Institute of Automation and Information Technologies, Gulnara Bektemisova, Candidate of Technical Science, International University of Information Technologies. A quorum for holding the council meeting is present. I propose to begin the work of Dissertation Council. In today's Dissertation Council's agenda, the defense of dissertation by Muhit Januzakov for the degree of Doctor of Philosophy on the topic research of fault tolerance algorithms for reliable information processing under the educational program Computer Science. The dissertation was done at the Department of Computer Science, Faculty of Information Technology and Artificial Intelligence at Al-Farabi Kazakh National University. The dissertation is being defended for the first time. Scientific supervisors: Gulnar Balakayeva, Doctor of Physical and Mathematical Science, Professor, Al-Farabi Kazakh National University, and Paul Ejelchilvan, PhD, Newcastle University, UK. Official reviewers: Lazat Naizabayeva, Doctor of Technical Science, International University of Information Technologies, Ayman Moldagulova, Candidate of Physical and Mathematical Science, Kazakh National Research Technical University, named after Satbayev. Dear colleagues, any questions on the agenda? If you don't have questions, let me kindly ask you to approve the agenda and give the next speech to the scientific secretary, Mr. Joldas Burbayev, to present and review the applicant Muhit Januzak's personal documents for the compliance with the approved requirements.
Thank you very much. Muhit Januzakov was born in 1998 in the city of the Semey, Abay region. In 2020, he obtained a Bachelor of Natural Science degree in the specialty 5B 060220, computer science. He then obtained a Master of Technical Science degree in the specialty 7M 06104, computer science. From the 2022 to 2025, he studied in the doctoral studies under the educational program 8D 06103, computer science at the Al-Farabi Kazakh National University. Since 2025, he has been working at the Al-Farabi Kazakh National University at the Department of Computer Science and currently works as a lecturer at the Department of the Computer Science. In accordance with the rules of the dissertation council, the doctoral candidate's personal file contains the following documents. First, the dissertation in the hard cover and electoral media, an abstract of the dissertation in the three languages, say Russian and English and Kazakh, review from local foreign scientific supervisor, certificate with the official seals their place of employment, the cancellation of protocol of the extended meeting of the Department of Computer Science with the positive decision on the submission for defense, approved by the signature of the Vice Rector for Research and Innovation of Al-Farabi Kazakh National University, the list of the scientific publications approved by the Scientific Secretary of the Al-Farabi Kazakh National University, and copies of the scientific publication related to the dissertation topic. According to the results of the doctoral candidate Muhit Janzakov's research, a total of the 8 scientific works have been published, including the 3 publications in journal indexed in the Scopus and the Web of Science International databases, 3 publications in the journal accommodated by Committee for Quality Assurance in the Science and Higher Education of the Republic of Kazakhstan, 2 publications in the proceeding of the international conferences and the editions, foreign scientific conferences indexed in Scopus, a copy of the identity document, personal employment record sheet, the certificate by the Human Resources Department of the Al-Farabi Kazakh National University, notarized copy of employment record book, notarized copies of the higher education and master diplomas and their supplements, a copy of the transcript confirming full completion of the doctoral study program certified by the seal of the Al-Farabi Kazakh National University, copy of orders approving the dissertation topic of the scientific supervisors, application for selection of the dissertation council with the resolution of the Vice Rector for Scientific and Innovative Works of Kazakh National University, doctoral candidate's application for admission to defense with the resolution of the chair of the dissertation council, protocol of dissertation council meeting on acceptance of the dissertation for defense, conclusion of the ethics commission of Al-Farabi Kazakh National University, certificate from the National Center for State Scientific and Technical Expertise on plagiarism check, and the reviews of the official reviews. The documents of the doctoral candidate Muhit Januzakov comply with the requirements of the Quality Assurance Committee in Science and Higher Education of the Republic of Kazakhstan.
Thank you very much. Dear colleagues, do you have any questions for the scientific secretary on the personal documents of Muhit Januzakov? If you don't have questions, we would like to give next speech to the Muhit Januzakov to outline the main content of his dissertation thesis. You have 20 minutes.
Thank you. Good afternoon, dear dissertation committee. Let me introduce myself. My name is Muhit Januzakov, and today I will be presenting my dissertational work titled Research of Fault Tolerance Algorithms for Reliable Information Processing. This work was done as a part of a scientific project called development of a scalable, fault-tolerant information system for digitalization of enterprise systems using big data technologies. The relevance of this work lies in the fact that reliable information processing has always been a fundamental requirement in modern distributed environments, where system failures may result in substantial production losses and safety risks. And existing fault tolerance mechanisms often suffer from high performance overhead. So here in the figure 1, we can see the enterprise server market growth rate by regions. And on this figure, we can say that mostly in developing countries, the enterprise server market is growing rapidly, and this includes Kazakhstan. And in the figure 2, we can see the predicted enterprise server market growth by the end of 2029, and it suggests that it will increase by approximately 50% compared to 2024. So this all data shows that the enterprise market will grow, will increase in numbers, and that's why the demand for the fault tolerance of these servers will also increase, and that is the relevance of the work. And the aim of this research is to develop and analyze fault-tolerant information processing algorithms for distributed enterprise systems that minimizes performance overhead and ensures fast and reliable rollback recovery with an optimized checkpointing interval. The tasks of the dissertation includes research of fault tolerance algorithms for reliable information processing, development of model-based fault tolerance algorithm for computing checkpointing interval in distributed enterprise systems, and the development of fault-tolerant algorithm based on queuing theory for computing checkpointing interval, and implementation and testing of new fault-tolerant algorithms in a real-world distributed environment. So we bring the following revisions to the defense. Development of new algorithms for calculating optimal checkpointing interval for fault-tolerant algorithm in a real-world distributed enterprise systems, and development of an algorithm for calculating the optimal checkpointing interval based on queuing theory, which demonstrated a system availability of up to 96% and achieved an improvement in overall system efficiency of approximately 3 to 4% compared to traditional algorithms. The novelty of this research includes designing new fault tolerance algorithms for calculating the optimal checkpointing interval and development of new algorithms for calculating the optimal checkpointing interval for real-world enterprise distributed systems. So in the research, the first thing we did, we reviewed and analyzed existing fault tolerance algorithms, and for that we used the following. In the assessment, we used the following metrics. So they were assessed by performance, scalability, complexity, fault tolerance, consistency, and resource utilization. The results of the review and analysis can be seen in Table 1. Here we can see that the rollback recovery with checkpointing showed the best balance between performance, complexity, consistency, and the resource utilization. That's why we try to implement this algorithm in our distributed system. And we came across a design challenge during this, and I will talk about it in the next slides. So first, let's look at the how this algorithm works. So as you know, the rollback recovery algorithm is a fault-tolerant algorithm that allows to recover server or system to a consistent state using checkpointed states called checkpoints. So one of the use cases of this algorithm is in a distributed enterprise system with primary and backup servers and shared database. So when the system is up and running, the servers take checkpoints at a specified interval. And whenever one of the servers crashes, the backup server will cut the last checkpoint from the database and try to restore the primary server. The design challenge of this algorithm was that how do you find the optimal value for the checkpointing? Why is it important? Because writing data to the storage is expensive, and that's why checkpointing too often will increase the overhead and the response time during uptime periods, and will also require a large storage capacity. But on the other hand, if checkpointing is performed rarely, then the recovery time will be long and the service unavailability will be long. So that's why we propose two algorithms for calculating the optimal checkpointing interval, and we compared them with the existing solutions, and they were categorized by the dynamic, static, and whether they are tested in a simulation or tested in a real environment. So here you can see that our works, they are both dynamic, and also they were both tested in simulation and real-world environment as well. So the first algorithm is actually based on the CPU capabilities of the server. So we take into account the CPU frequency, and also we calculate the mean execution time of a task on a single-threaded CPU. So using that, we calculate the checkpointing interval. So the logic here is that the highest CPU frequency allows us to take more checkpoints and vice versa. Here's the pseudocode of the algorithm, number one. We here the commutative distribution function to find the array under CDF, and using that we can find the mean execution time. And then at the end we calculate the optimal checkpointing interval. The next algorithm that we use is based on queuing theory, laws, and parameters. So here we try to find the total time, including all the different parameters such as repair time, backup time, checkpointing interval, and etc. So, and after that, we calculate the expected number of jobs in the system according to Plachek-Hinchen formula. Then here the most important part is we check the stability condition, and the system is considered stable if the load generated by service time of upcoming jobs is less than 1. So if our checkpointing interval satisfies this condition, then we think that then we can say that this checkpointing interval is optimal. Here is the pseudocode and the workflow of the algorithm. This is a simplified pseudocode. So here we try different values of checkpointing interval and calculate the load, the expected number of jobs in the system. Then we check the stability condition if it is satisfied. So at the end, we try to find the optimal checkpoint interval that produces minimal load to the system as well as satisfies the stability condition. In order to test and compare these algorithms with the existing ones, we implemented two experiments. In the first experiment, we implemented a world enterprise distributed system using virtual machines. So we used the Dockers, and here each Docker container is denoted as node. So we have 6 nodes, and the 5 nodes as a primary node, and the 1 for backup node. And they had a shared disk, and the duration of this experiment was 10 hours with a specified arrival rate, and then we also simulated breakdowns at a specified probability. And during these experiments, we used the following metrics to evaluate the algorithms. We used number of checkpoints, average service time, availability, which shows the percentage of time a system is operational, and as well as efficiency, which measures how efficiently the system uses its resources. The results of the experiment 1 can be seen in table 3. Here we can see that the first algorithm that we proposed showed the best average service time, And the second algorithm, based on queuing theory, showed best availability and system efficiency. The next experiment was conducted using physical machines. So we connected 4 computers together, and each computer here is denoted as node. So the first node was used to calculate all the tasks. It was used as a primary node, and the second node was used as a backup node, and the third one was used to generate workloads, and the fourth one was used to store the checkpoints and other metrics collections. It was also run for 10 hours with a specified arrival rate and the breakdown rate. The results of this experiment can be seen in table 4. Here we can see that the queuing-based algorithm showed the best results in average service time, availability, and system efficiency. And to further test the performance overhead of these developed algorithms, we conducted additional simulations. So here we created 2 environments. One that can be seen in figure 10. These CDF of execution times with and without checkpointing in an environment with no crashes. So here we can see that the algorithm that we propose added about 40 milliseconds of overhead. However, if we look at the figure 11, we can see that we built a CDF of execution times with and without checkpointing in an environment with crashes. So here we can see the benefit of using checkpointing. So the algorithm, when we use the algorithm one for calculating the optimal checkpoint value, the execution time is almost stayed the same as in figure 10 with no crashes. So and the not using checkpointing actually increased the execution time by almost 2. So here we can say that the checkpointing allowed us to maintain the same execution time even in crashes. The same experiment was done with the algorithm number 2 based on queuing theory. Here we also can see that the performance overhead is quite small, and it also maintains the same value for the environment with a lot of crashes. To discuss the results, we can say that the model-based algorithm, it minimized service time due to frequent checkpointing, but the queuing theory-based algorithm provided the best balance between reliability, efficiency, as well as performance. And classical algorithms, they either generated insufficient checkpoints or excessive checkpoints. To conclude the work, different fault tolerance algorithms for reliable information processing is researched and analyzed, and the model-based fault tolerant algorithm for computing checkpoints in interval in distributed enterprise systems is developed and implemented in a real-world environment using virtual and physical servers. Fault tolerance algorithm based on queuing theory for computing checkpoints in interval is developed and implemented in a real-world environment using virtual and physical servers. And the results of the study can be used in high-performance computing systems, cloud computing platforms, distributed data processing systems, and enterprise distributed systems. Here is the publication list of the research work. That's it. Thank you for your attention. If you have any questions, I'm ready to answer them. Thank you.
Thank you very much for your presentation. Dear members of dissertation committee, if you have questions, you're welcome.
Let me start. Dear Muhit, thank you very much for your interesting presentation. And as you reported, you developed 2 models, 2 algorithms, model-based fault-tolerant solution and fault-tolerant algorithm based on the querying theory, yes? And could you please explain the novelty of each of these algorithms? Because we understand the importance of distributed computing and the problems of fault tolerance and the reliable work of the big systems as cluster systems, and we understand the importance. But let me understand more detailed on the level of the algorithm. Thank you.
Thank you for the question. The novelty of each of the algorithm is that the first algorithm that is model-based. So here we utilize the CPU frequencies. So these capabilities of the server, physical capability of the server, as well as we utilize we model the system such that we try to find the mean execution time and use it for the checkpoint interval. So this was never done before. And the second algorithm that is queuing based, it is also new. So here we utilize the stability condition. So we check if the system stays stable throughout the uptime period of the service or the system, so that the number of jobs will not increase infinitely. So this is a new algorithm, and it is really good for the systems with high breakdown rates and as well as long running jobs.
Okay, and did you implement the experiments on the real systems, and what can you say about it, about the results? Yeah, of course, we can do experiments in some simulation with simulation models and machines. Did you have the experiments in with real systems?
Well, we tried to implement the real world environments. So we used virtual machines, Dockers, and it is really common in enterprise systems. So that's why we use it. And also we implemented the using real computers. So we tried to sort of implement it as real as possible. And we also did simulations, just the simulations. We specify the checkpointing rate, and we simulated the breakdowns, but we also did using physical machines. So I think that can be applied to any enterprises.
What about the results on real systems?
And the real systems, it showed good results. Actually, we can see that in the experiment results in the table. Let me show it. Yeah, here we can see that our algorithms maintain the actually the queuing theory-based algorithm maintain the good availability and system efficiency. So we can say that these algorithms can show a good result in real distributed systems.
Okay, thank you.
Other questions?
I have the question.
Mm-hmm.
Actually, during that presentation, I haven't seen the strict mathematical formalization or formulation, the corresponding mathematical models for that system, for this kind of distributed system that consists of several nodes. So actually, the closest way to represent the distributed systems is to represent them in terms of graphs with different features on the nodes, features on the edges, and so on. So could you explain, did you apply some kind of this formalization, strictly mathematical formalization of your system, and how your parameters you have listed here could be reflected in the features of this kind of model. Was it clear enough, my question? So I ask about the strictly mathematical formalization, about the strictly mathematical formulation and mathematical model.
Yeah, thank you for your question. So here we try to use the so each server has its own checkpoint interval. That's why we can say that this model applies for each server individually. So that's why we didn't include the multi-servers to the model to make it as simple as possible for enterprise distributed systems.
But actually you have formulated the problem as the problem that concerns the distributed system. So we actually have to expect that at least we will consider several nodes and we will take into account the relation between them, maybe the delay time between the interaction.
Yes, so we implemented distributed systems using several nodes, several computers, and the experiment results are good. So it suggests that the algorithms that we are proposing, they actually work on multi-noded systems. So is this what you mean?
Okay, thank you. We will discuss further, I think.
Other questions?
Can I ask?
Yes, of course.
I would like to ask one question. Does the algorithm adapt to different fault tolerance paradigms?
Different paradigms?
Adapt. Does the algorithm adapt to different?
Thank you for your question.
Mhm.
Yes, it adapts. So each system, any server has its own capabilities, such as CPU frequency, and each enterprise servers can calculate different tasks. So we calculate the mean execution time for this, and we also incorporate the CPU frequency of the individual servers. So that's why it can be adapted to any system.
Thank you.
Dear colleagues, you can ask the questions in all three languages if you want, in Russian, in Kazakh, in English.
I have one question.
Okay.
How did you prove that the proposed algorithm is reliable and stable?
Thank you for the question. So in the experiments, we use the metric for each, for the availability and efficiency. So these metrics are universal. So, and they indicate the how the algorithm performs in operational times, and including breakdowns and other failures. So that's why we used it, and the experiment results show good results. That it indicates that our algorithms, they're actually good at handling failures and being reliable.
Sorry, I have a second question.
Yes.
Why did you choose the grow worm swarm optimization algorithm to solve the fault tolerance problem?
Can you please repeat?
Why did you choose the GSO algorithm to solve the fault tolerance problem?
GSO?
Glow worm swarm optimization.
I'm sorry, but we didn't include this algorithm in our work.
I'm sorry. Thank you so much.
Other questions?
I have a question. Actually, you've discussed about fault tolerance, but maybe I've missed the version on how you injected these failures actually to your models. For example, in experiment 2. Is it clear? Should I repeat the question?
How do I inject it?
Because you are actually testing your system against faults.
Yes.
I mean, okay. So, how did you injected these faults to your system to check the residence, okay.
Yes. I think I understand your question. Thank you. So we each node or the computer calculated the checkpointing interval and used it for the checkpointing. And there was an orchestrator that there was a script that it was injected into each of the nodes that said, okay, if there are failures, then you need to like restore this server using the last checkpoint from the shared database. So they all had the shared disk and the load balancer as well. So this is how it was injected and used for handling faults.
Okay, then next question. You said that you injected these faults to your system using some architect. So were they injected in some random manner? Did you have some, I don't know, some statistical tests for testing your results?
Thank you. So we, in order to simulate the breakdowns, we set the breakdown rate as 0.1 failures per second. So almost 10 of the tasks, one of them was
a failure.
Hmm?
Oh, each 10th task was a failure. So in your useful time, you use this catch-up statistics to prove your efficiency. Did I get it correctly?
Could you repeat, please?
Okay, you said that you use these injections. I mean, 10 tasks, and each 10th was some failure, right?
One of the 10 tasks was a failure.
Okay, so you just while you said that there was some useful time for efficient formula. So in this, it means that you just calculated the times where your algorithm was actually able to catch the failure to calculate the accuracy of algorithm, right? Here.
Yes, so
okay.
here we calculated the uptime period of each server and the downtime. So uptime means the server is running and computing tasks, and the downtime is when it is not computing tasks and it is failed. So we
Yes.
use this formula for
Yeah.
to calculate availability.
Okay, thank you. I've just missed this slide. Sorry. Okay, thank you.
Thank you.
Dear colleagues, any other questions? If you don't have questions, I have one more. Mohit, it's not clear for us what is the conceptual difference between your algorithms and the other approaches. You mentioned in slide 19 or 20.
This one.
Yes, this one, this algorithm.
So, thank you.
It will also ask for the answer for the question about novelty of the work, of your work.
Thank you. So the difference between our algorithms is that they are dynamic. It means that whenever the circumstances change, one of the parameters change, such as breakdown rate or arrival rate, then we recalculate the checkpoint interval, and it was tested in a real-world environment. So we tested using virtual machines and physical machines, whereas other works, they used mostly simulations. So that's the main advantages of the algorithms.
Optimization criteria. You mentioned 4 in the slide 19. Next. System efficiency, availability, number of checkpoints, and the service time. Why did you, what can I say? Why did you choose number of checkpoints and the question is you can do it only for the availability and the average service time. Why did you make accent on the number of checkpoints and the system efficiency? Why it's important?
Thank you for your question. So the number of checkpoints was used to show how much space, how much storage is needed for each of the algorithms. So we wanted to see the impact on storage capacity and system efficiency. We tried to use how each algorithm affects on the resources such as CPU, energy, etc. So here we use useful time, meaning that the time when the system is working and available, and as well as total time. So here what we wanted to show is that our algorithms, they minimize the not minimize, but maximizes the system efficiency. So the CPU and the energy, such as electricity, is as efficient as possible.
Okay, thank you. Dear colleagues, I think there were enough questions.
One more question, sorry.
Okay.
Again, concerning these checkpoints, in your algorithm one, there are so many checkpoints. I mean, much more than in the other algorithms, but still the worst availability. How would you explain this paradox?
Thank you. Yes, so the idea is of the first algorithm was to utilize the CPU frequency. So the algorithm itself says that we need more checkpoints to minimize the average service time, but it doesn't care about availability and system efficiency as other algorithms. And however, the second algorithm, for example, it used almost half of that size. So we can see that this number of checkpoints is needed for maximizing availability and efficiency, and this number of checkpoints is needed for achieving the best average service time, to the minimal average service time. So yeah.
Okay, thank you. Thank you.
Thank you very much. I think we've discussed this work in detail, and there were enough questions. So I would like to go to the next step of our dissertation committee's work. So the first speech. The next speech will be given to foreign scientific consultant, PhD, Professor Paul Hijelchilvan.
Hello, can you hear me?
Yes, we can hear you.
Oh, thank you very much. I think this dissertation, PhD dissertation, is generally a good one. As I put it in my reference letter, we worked on some modeling. The novelty of modeling is basically, as Mukit said, it's quite dynamic. The existing ones take some predefined parameters and then come up with some model. And if situations change, it cannot be accommodated. So the queuing theory gives that flexibility over the existing models, where we can kind of accommodate fluctuations in the workload and all kinds of things. And the second aspect of this beautiful work, is this: it's very hard to translate the model in terms of implementation. Because, for example, model assumes Poisson arrival rate and all kinds of things. So how we are going to implement the model in real world settings. And in that aspect, this thesis, in my opinion, makes a very good contribution, because they have taken the model, developed two algorithms based on it, and then they were really implementing it and testing it as well. So that is implementation is another important aspect of systems research in computer science. There is little mathematics there, but there's a good way. You need a deep understanding of mathematics, right? So the experiments, that is a second contribution. And the third contribution, in my opinion, is the evaluation, like fault injection, how to inject faults. I mean, basically, this checkpointing algorithm, the two algorithms are developed to deal with crash tolerance. And then we need to inject crashes to show how quickly they recover. right? So there was there are quite a lot of experiments without fault and with fault. So these two should be conducted together. So in that sense, it establishes the benefit of having checkpointing, so that when the system ever crashes, we just recover very quickly. Whereas in the absence of checkpointing system, when something crashes, that's it. We have to go back and start from zero, right? So this is an important one aspect, showing the benefits. And of course, there is a cost. And that also we measured, I think Mukit measured here, which is to show, like, you have no checkpointing and no failures. What is the there is zero overhead. But now you put checkpointing, but no failures occur. So there is so you measure it and see how the system slows. Every fault tolerant measure, in my opinion, will have some performance overhead. So when the crashes do not happen. So given that scenario, how we are going to, what is the overhead? So in both aspects, these measurements aspects are also the third and good contribution. Usually we expect 3 or more contributions, and then in addition to literature survey and all those things. And in my opinion, a PhD student should understand the landscape, the research landscape, the research background, and I also see there is a good understanding, depth of understanding in that area. So I have no hesitation in recommending this PhD dissertation. Thank you.
Thank you very much, Professor Paul Ejilchevan.
Thank you.
Next speech will be given to Professor Gulnar Balakayeva.
Thank you. This dissertation addresses two pressing scientific issues aimed at ensuring the reliability and stability of modern information systems. The relevance of this research is justified. Increasing complexity of computer system, growing risk of failures of distributed systems, and requirement for reliable information processing in enterprises. All objectives set in the study have been fully accomplished, and applicant investigated fault tolerance algorithms, designed new algorithms, implemented them in experimental environment, and conducted testings. The results were compared with traditional methods, and efficiency of the proposed approaches was demonstrated. The results of the dissertation have been presented in international conference in London in this summer. Will be conference, last conference, and published in domestic and foreign scientific journals. All articles is 9 articles, and in scientific project development of fault tolerance information systems. The applicant independently conducted the scientific research and affection applied model programming. In conclusion, the dissertation work of Januzakov M.B. on the topic research of fault tolerance algorithm for reliable information processing has been carried out on high scientific level, meets the requirement of the rules for awarding scientific degree of the Science and Higher Education Quality Assurance Committee of the Ministry of Science and Higher Education of the Republic of Kazakhstan for the degree on the specialty 8D06103 Computer Science, and is considered worthy on the degree of Doctor of Philosophy PhD. I believe that the candidate fully deserves to be awarded the degree of Doctor of Philosophy, PhD in relevant field. Thank you very much.
Thank you, Professor Gulnar Balakayeva. Dear members, we have also 2 official reviewers for this dissertation work, and let me give the next speech to the first official reviewer, Doctor of Technical Science, Liazat Naizabayeva.
Thank you. Can I give a short version because you can see full version on the official website? My review of the official reviewer for dissertation work of Muhit Januzakov and the team research of fault tolerance algorithms for reliable information processing presented for the degree of Doctor of Philosophy and Specialty Computer Science. First criteria was about compliance with priority areas. Yes, this dissertation was carried out as part of the scientific project from 2021 to 2023. Second option about in this area, the dissertation corresponds to the priority direction of science development approved by the High Scientific and Technical Commission under the government of the Republic of Kazakhstan, namely Advanced Production, Digital and Space Technologies Direction. Next point is about importance of science. The work makes a significant contribution to science, and it's important and is well disclosed. Next, the principle of independence and the level of the candidates independence is assessed as high. Next, the relevance of the dissertation is fully justified. The content of the dissertation fully reflects its topic. And next is about aim. The aim and objectives, the research correspond to the dissertation topic. Correspond, yes, and all section and provisions dissertation are fully interconnected. In the dissertation, the author conducted a critical analysis of the existing solution, methods, and approaches. The scientific result is provisions of the dissertation are partially novel. The conclusions, the dissertation are fully novel. In particular, the novelties reflect in the integration of the imperial model and the optimal algorithms. And the next point is about technical and technological economic management decisions. They are completely new. All main conclusions are based on scientifically significant evidence or well-grounded. And next point is about the main provisions for the defense. Prevences proven, trivially no, novelty yes, level of application wide, prevences in the article yes. The choice of the methodology is well-founded and described in sufficient detail. The results of the dissertation were obtained using modern scientific research methods. Sorry, reviews very on the 20 page, yes, full. I tried to give the short version. The theoretical conclusion developed models and I defined patterns, and the dissertation are well-founded and confirmed by the result of experimental research. Next point about important statement are confirmed by references to current and reliable scientific literature. Use literature sources as sufficient for a literature review. Next point, in the course of the research, concrete algorithms for the reliable information processing in distributed enterprise system were developed and implemented in software. About suggestions new, they are partially new. from 25 to 75%. And about academic writing quality, I can write high. My notes was 2 points. First was about structure and coherence and presentation, and second was about terminological consistency. The above remarks are the recommendatory nature and not affect to the overall positive evaluation to the dissertation research. The scientific level of the doctoral candidates' articles on the research topics meet the requirement for publications in the profile of the dissertation work. And finally, I consider Mukhit Januzakov to be worthy of the degree of Doctor of Philosophy in specialty AD 06103, Computer Science. Thank you.
Yeah, thank you. Would you like to respond to the reviewer's comments?
I completely agree with the comments and the notes of the review.
Thank you. If the next speech is for official reviewer from Satpayev University, candidate of Physical and Mathematical Science, Ayman Moldagulova.
Thank you very much. Dear Chairperson, members of the Dissertation Council, colleagues, I have reviewed the doctoral dissertation entitled Research of Fault Tolerance Algorithms for Reliable Information Processing, submitted for the degree of Doctor of Philosophy in the degree program AD 06103, Computer Science. The dissertation addresses the important and highly relevant problem of ensuring reliable information processing in enterprise distributed systems. The research was conducted within the framework of state-funded scientific project development of a scalable fault-tolerant information system for enterprise digitalization using big data technologies, which confirms both its practical relevance and theoretical significance. The dissertation consists of 4 chapters and presents a comprehensive study of fault tolerance methods, load balancing algorithms, rollback recovery mechanism, and enterprise distributed system architectures. Based on the extensive analysis of existing approaches, the author, Mukhit Januzakov, justifies the selection of rollback recovery with checkpointing as an effective mechanism for improving reliability in distributed computing environments. The scientific novelty of the work lies in the development of 2 original approaches for calculating optimal checkpointing intervals. The first is a model-based solution that determines checkpoint intervals using execution time characteristics and processor performance parameters. And the second one is an algorithm based on a queuing theory, which enables adaptive optimization of checkpoint intervals under varying workload and failure conditions. Particular attention should be paid to the practical validation of the proposed methods. Unlike many previous studies limited to simulation, the developed algorithms were implemented in the tested in both virtualized and the physical enterprise environments. The author, Mukhit Januzakov, has published 9 scientific papers reflecting the main results of the dissertation, including publication indexed in Scopus and journals recommended by the authorized body of the Republic of Kazakhstan. The publication confirmed the scientific significance and the international visibility of the research results. The dissertation is a complete and well-structured scientific work. The author, Mukhit Januzakov, demonstrates a solid theoretical background, proficiency in the modern research methods, and the ability to solve complex scientific and engineering problems independently. The obtained results well substantiated and supported by theoretical analysis and the experimental verification. At the same time, broader generalization of the proposed methods and comparison with a wide range of alternative fault tolerance approaches could further strengthen the work and may serve as the direction for future research. In conclusion, the dissertation fully meets the requirements established for doctoral dissertations. The scientific results possess novelty, theoretical significance, practical value, and contribute to the development of distributed systems and fault-tolerant computing. Therefore, I support the award of the degree of Doctor of Philosophy in the degree program AD 06103 Computer Science to the candidate Mohit Januzakov. Thank you very much for your attention. This is a short and my full review in the official website.
Yeah. Thank you very much. Thank you. Mohit, would you like to respond?
I completely agree with the review and the comments of the reviewer.
Okay. Dear members, we are going to the next part of our work. It's a discussion part. If you would like to speak, please.
I have some speech for Mohit. Oh, I know Mohit from the Mohit's master's degree, and I know the only good good sides Mohit. How I know Mohit was one of the best master students in the his groups, and I see his work is classical topics. I mean the classical tasks from the computer science, and how you see how we understand Mohit finished the goal, his goal, and take good results. It's shows his prints one of the journals were indexed by Scopus. I think it's good job for us, and I can say good luck. It continues good results. Take a good results.
Thank you. Dear colleagues, would you like to speak? You can do it
Actually,
in Russian, in Kazakh, if you want.
Okay, could I say several words? I would like to wish to continue this kind of research because it seems very interesting and include much more complicated structure of the network. Maybe use some kind of theory for the graphs and consider the workload of different nodes and make the synthesis of your work with the workload on one node and consider the way, for instance, of the signal from one point to another point going through several servers. So I see big possible continuation of that research work. That's my little remark about that work.
Thank you. Dear colleagues, I would like to also support this dissertation work because of the several reasons. Firstly, I will be very short. Firstly, this dissertation work addressed to the very important and practical problem in distributed systems. Secondly, Mohit and his supervisors provides new algorithms, new approaches for optimizing optimizing checkpoint intervals here. The one of the main thing is this approaches are tested in both in virtual and physical distributed environments. So very interesting, unusual dissertation work. I am very happy that this kind of works, which is not related to artificial intelligence, are presenting in our dissertation committee. So I believe that this work will be evaluated positively. So thank you. And let's go to the next part. We have the procedure of the voting procedure. So voting procedure. The scientific secretary will send you a link for the online voting to your personal email or WhatsApp numbers. There will be 4 possible answers in the voting form. First one is award the degree of Doctor of Philosophy or Doctor of award the degree of Doctor of Philosophy. Second one is send dissertation for revision. Third one to refuse to award the degree of the Doctor of Philosophy. And the last one is submit the dissertation for redefense. So you need to choose one of them. And now there will be a 5-minute break for the voting. I would like to remind that official reviewers also will be voted. Dear colleagues, voting is finished. So, according to the voting, we can see from the slide that our dissertation council evaluates Muhit Januzakov's dissertation work positively. So, based on the open defense of the dissertation at the Dissertation Council of Al-Farabi Kazakh National University and the results of online voting, it's resolved to award Muhit Januzakov the academic degree of Doctor of Philosophy under the educational program AD 06103 Computer Science for the dissertation entitled Research of Fault Tolerance Algorithms for Reliable Information Processing. So congratulations, Muhit, and you can say a couple of words for your supervisors, maybe.
Yeah, thank you, Mr. Chairman. I would like to say my thanks for my local scientific advisor, Gulnar Balkaeva, and also for the foreign scientific advisor, Paul Izichilvan, for your support and help along this journey. And I want to thank all the members of dissertation committee for the consideration and assessing my PhD dissertation. And thank you for everybody.
Okay, dear members of committee, now we are finishing our work, and I would like to thank all of the members of this committee, especially temporary members and official reviewers who are participating offline. Good luck for everyone, and see you on the next committee sessions. Thank you.
Жақсы, рахмет, сау болыңыздар.
Сау болыңыздар.